Hello and welcome back in our continued journey of mastering algebra and even more specifically working with the modulus function. And today today onwards we want to handle problems which look like this or in the same vein. So I can add more expressions here, the factors could change, the coefficient of x will change, but basically a mod plus mod plus mod or just two mods being added together. How do I handle such a situation? And we'll do it by using three distinct methods. All maths is the same idea, just three different interpretations. Obviously, first of all, I want to start with the standard algebra, condition driven, systematic thinking method, and then I will go for a story interpretation, and then I will go for a visual graphic based interpretation. You can finally choose your shortcut, whichever one works for you. But let me warn you, while we are building the shortcut, the explanation might become slightly long because I really want to understand the idea clearly. But once you understand the idea, you will see the shortcut works very, very quickly. So there might be some effort in learning, but once you reach the end point of the shortcut, you can also just blindly reach the end and just look at the shortcut as such anyway. But if you understand the process, you will see a lot of speed in a reasonably complicated situation. Most people would have found this at least difficult looking, especially beginners, right? So let's first work with the standard story, and even there let me plot the roots of each expression on the number line, right? That means if I put 2 here, this becomes 0. If I put 5 here, this becomes 0. And now let me think of the region step by step. What happens beyond 5? And what is my standard method? My method is to think, okay, this will give me 2 stories, but this will also give me 2 stories. So perhaps there are overall 4 stories, right? This is positive, this is positive, this is positive, this is negative, this is negative, this is positive, etc., etc. So I know that's my general thought. That's what we have been doing in the modulus function all along. So same story, but first let me observe the number line, and my roots are 2 and 5 for each expression. And now I'm thinking, let me go, I have regions to think about, makes my thought process easier, right? So I'm going beyond 5 and I'm thinking what happens in if I go beyond 5 to the expression. Let's say 6, right? This will be positive. Why am I doing all of this? Because my basic definition of mod is mod of x is x when x is positive, and it is equal to minus x when it is negative. So I'm very interested in this region, what is the inside value going to be, positive or negative? And I look at the expression, I know the moment I go beyond 5, this will be positive. 7 minus 5 is 2, 9 minus 5 is 4, all positive values. And let me observe this also simultaneously. If I go for any number beyond 5, this will also be positive. Okay. That means if I am thinking only of beyond 5, what is going to happen to this mod? It will just come out as x, because I know x is positive, because I know x minus 5 is positive. So I am writing the same equation with the mods removed. I will say I know instead of this point I can write x minus 5 just to connect it to the equation. Equal to 9 I can copy anyway. That's an easy copy, right? Again, this is also positive, so even this mod will simply come out as x. That means whatever is written inside, just write it like the way it was written without the mods. And there is a plus in between. So x minus 2 plus x minus 5 is equal to 9. Simplify this, you get a 2x. A minus 2 and a minus 5 will give you a minus 7. Move it over to the other side, you will get a plus 7. 9 plus 7 will give you a 16. Please do solve it for yourself. And x is equal to 8. Always check your story, get into the habit of checking your stories. 8 minus 2 is 6, 8 minus 5 is 3, 6 plus 3 is going to give you 9. Perfect, the solution works for me, right? So I'm using the same two-story approach, but starting with each number might have been difficult, so I'm plotting it on the region, not really plotting it, just thinking what are the regions, what is going to happen beyond 5. And in one more step it will become better and better, right? Between 2 and 5, that means 3 or 4 or 4 and a half. If you put a number like that here, 4 minus 5 will give you a negative number. That means x is negative. That means whatever is inside, the mod sign should be removed, but a minus sign should be put up. So instead of this, I will write x minus 5, but there is a minus here. This is equal to 9. I'm just copying anyway. Again think of this region between 2 and 5, this expression is going to be positive. That means x is positive, x is whatever is inside the mod, right? That means I can just write it the way it is. Whatever is written inside the mod, I can just bring it out. So I will write x minus 2. There is a plus between, the plus multiplied to the mod, right? But instead of the mod, you are writing a minus into x minus 5. So even if you throw in the plus here, the plus into a minus will give you a overall minus only. So pay attention to this step, or simply remove the bracket, make it a minus sign, and make your life and mine easy. Now solve this equation. I have a x, I have a minus 2, I have a minus x, and a minus into a minus 5 will give you a plus 5. This is equal to 9 is what I have to solve. X and x gets cancelled. Minus 2 plus 5 gives you 3. 3 equal to 9. What a silly equation. That means this region is just not going to work for me. And again, regions or solutions not working is again something that we have seen, that I know there is no point between 2 and 5 which will satisfy this equation and make it equal to 9, right? Let me think of the other region now, below 2. What is going to happen in this story? If I go below 2, this will be negative as well as this will be negative, right? Please check each step for yourself, slow down, interpret in your own language. Any number less than 2, I put a 1. 1 minus 2 will give you a minus 1. 1 minus 5 will give you a minus 4. That means x in the story is negative. That means I should take the mod out and put a minus sign here. That means instead of a x minus 2, I will write a minus of x minus 2. Instead of a x minus 5, I will write a minus of x minus 5. I already know this plus into this minus will become a minus, so I am just making my life easy and writing it so. This is equal to 9. What do I get? A minus x, a plus 2, a minus into a minus 2, a minus x and a plus 5. This is equal to 9. What do I get? Minus 2x plus 7 is equal to 9. So plus 7 is equal to 9. So minus 2x is equal to 2. That means x is equal to minus 1. And again, check the story for yourself before you wreck your story. Put a minus 1 here, you get a minus 1 and a minus 2 is a minus 3. Mod of that will give you a plus 3. A minus 1 and a minus 5 will give you a minus 6. The mod of that will give you a 6. A 6 plus 3 will give you a 9. So now, and we are done with the problem. Two possible solutions, x is equal to 8 and x is equal to minus 1 will definitely work for you. So this is our standard method, this is our old method. The problem, not really a problem, but let's say from the testing with a limited time point of view, is that if I extend the situation, if I say mod of x minus 2 plus mod of x minus 5 plus mod of x minus 8 is equal to something, the story even on the number line becomes slightly bigger and complicated and cumbersome. You go the process is still the same, the idea is still easy. Region by region, beyond 8 everything will be positive. Between 5 and 8 this will be negative, but these two will be positive, and there's not a product, so you just have to copy the equation in a certain way. Between 2 and 5 both of them will be negative, but this will be positive. Below 2 all three will be negative, and each time you'll have to create the equation, solve it, create the equation, solve it as such. So now I want to look at other approaches. I'm assuming that everybody can make sense out of this, and if you want to practice this, you can create your own equations, or when you hit the exercise you can use the standard method to solve them again, just to build comfort or challenge yourself mentally in terms of stamina and patience as such, right? But I want to look at alternate approaches, and they while again, as I said in the beginning, while learning it might take some time, but once you learn it will be very, very quick. And even the learning itself can be fairly revealing in terms of what new things are you learning and what clarity can be developed. So one is a story method based on the distance interpretation of modulus or a subtraction, and the other is based on understanding the graph of the modulus function. We have seen like the introduction to the graph function in the very beginning of the course, right? Like just as an introductory process. So we want to hit that process again and understand what happens when the graph of this is melted with the graph of this, and what is the outcome, and is there a shortcut there as such, right? So we'll do that, but even this method is fine. It is just that it is not competitive test exam kind of a special method. Those are the methods that are coming up next. those are the methods which are coming up next, and I would be fairly excited about what I am going to learn there and how I am going to interpret the same story from very new eyes as such.